Chapter 7.2, Volume, the disk method. Day 2, finding the volume of a solid revolution using washers. All right? Washer is just like a disk, except there's a hole in it. Think of a disk, pretty much a round, flat surface. Washer is the same thing, except we got a nice little hole in it. So what we're going to be doing is like we did with the disks. We're going to have a function. We're going to stack up our disks and add them up. Except now, there's going to be a little gap. So instead of going all the way to the axis of revolution, we're going to go just part way. All right? Just going to go part way. And so for that, we're going to do subtracting out the middle. So for washers, when we go part way, it's going to be pi r squared minus r squared, our two radiuses, times the width. Or, in calculus terms, we're going to integrate from a to b times pi large radius squared minus the small radius squared with respect to x. Where dx is the width, the large radius, and the small radius. Right, so let's look at a problem. All right? Find the volume of the solid formed by revolving the region bound by the graphs of square root of x and x squared about the x-axis. Okay, the figure is right here. All right, here's the square root of x. Here's x squared and revolving around this axis right here. So if we look, as we revolve, our outer disk will look like this. Our inner disk will kind of look like this. The large radius goes to the square root of x. So our volume will be pi from 0 to 1 of the square root of x squared. That's our large radius. And our small radius is right here. We subtract the whole out, which is x squared squared with respect to x. We'll clean that up and we'll integrate. So this is going to be x minus x to the fourth with respect to x. As we integrate, we will have 1/2 x squared minus 1/5 x to the fifth from 0 to 1. And so we'll end up with pi times 1/2 minus 1/5. Or 5/10 minus 2/10 is 3 pi over 10. All right. Looking at another example, now we're going to rotate around the y-axis. So we got to find the volume of the solid formed by revolving y equals x squared plus 1, y equals 0, x equals 0, and x equals 1. So in other words, they're just telling us the boundaries. Rotate it around the line or around the y-axis. So this time, our slices are going to stack up like this. They're going to be on the y-axis. So when we stack along the y-axis, we need to be with respect to y. So that means we need to solve all those. Well, there's really only one. So that y is our variable. So we'll subtract 1 and take the square root. So x equals the square root of y minus 1. Okay? And you see here, we kind of got disks here and washers here. So we're going to do it in two pieces. All right? So I'm going to do the disk piece first. It's going to be volume equals pi from, again, with respect to y. So looking at the y values here, this is 0, this is 1. And there's only one radius, it's 1. So 1 squared with respect to 1. With respect to y, sorry. Plus, and then we'll do the washers, because there's a little hole in there. It's not right up along the axis. So that'll be pi from 1 to 2 with respect to y. The outer axis is 1, so it'll be 1 squared minus the square root of y minus 1 squared, or we can just do y minus 1 with respect to y. All right? So we'll clean this up and integrate. We can just integrate here. This will be pi y from 0 to 1 plus pi, I'm going to clean this up, from 1 to 2 of 1 minus 1, or 1 minus negative 1 is 2 minus y dy. So we got pi here when we plug in the 1 and the 0, plus pi times 2y minus 1/2 y squared from 1 to 2. We got pi there, plus pi, that's 4 minus 2 squared is 4, half of 4 is 2, minus, and when we put in 1, we got 2 minus 1/2, so this is 2, this is 3/2, 2 minus 3/2 is 1/2, so we got pi plus half of pi, so 3 pi over 2. Right? So that area is 3 pi over, or I'm sorry, that volume when you rotate there is 3 pi over 2. Okay, let's look at one more practice problem. All right, we got a sphere and we're going to drill a hole in it. And we're going to use a radius, a drill with a radius of 3. The sphere has a radius of 5. Well, when you do that, really you're going to have a whole circle, and you're taking out this part right here. And so you can just wrote this part of a circle. Radius of a circle with, or the formula for a circle with radius 5 is x squared plus y squared equals 5 squared. Since we're going to cut that hole out, we can kind of simulate that as rotating around the x-axis. And in order to rotate around the x-axis and stack on the x values, we should solve for y. And that's where the square root of 25 minus x squared comes from. The hole has a radius of 3. So the y value equals 3. The x value then ends up being 4. And so when we integrate this, we're going to use our washers because there's a large radius, and then we cut out this. We're not right up against the axis of rotation. So it'll be volume equals pi from, since we're with respect to x, stacking along the x-axis, we use the x values for our limits. Pi from -4 to 4. Our large radius is 25, or the square root of 25 minus x squared. We're going to square it. That's just going to be 25 minus x squared, minus our small radius is this distance right here, which is 3. So that'd be 3 squared, which is 9, with respect to x. All right, we'll clean that up. That's going to be 16 minus x squared dx. All right, so it'll be pi times 16x minus 1/3 x cubed from -4 to 4. So it'll be pi times 16 times 4 minus 1/3 of 4 cubed minus 16 times -4 minus 1/3 of -4 cubed. Okay, as we clean this one up, it'll be pi 16 to the 4th, or 16 times 4 minus 16 times -4 would be like 16 times 4 twice, so that'd be 16 times 16. And then we'll have negative 1/3 times 4 cubed. This will actually end up being plus minus that. So again, it'll be like minus 2/3 for the third. And I'm going to stop there with that one. Again, on the AP exam, an equivalent answer is fine. If you want to plug it in your calculator, get something a little more, I don't know, user-friendly would be a good term there. I'll show you how to do that on the graphing calculator. We'll go math 9, since we're integrating, from negative 4 to 4. And we'll do the simplified form, 16 minus x squared with respect to x. We get 85.3 repeating, which is 256 over 3. Don't forget to multiply by pi, so this ends up being 256 pi over 3. Right. So in conclusion, when you're using the washer method, you use the washer method when you're going to have a gap. The shape you're rotating is not flush against the axis. And you're going to do the same thing. You can go from A to B, you're going to find the radius squared, but since there's a hole, you're going to subtract out the radius of the hole squared with respect to x, or if you're stacking the other way, with respect to y.